ሰላም የቻናላችን ተከታታዮች እንደምን አላችሁ? የ10ኛ ክፍል ፊዚክስ አዲሱ ካሪክለምን ዩኒት 1 ቬክተር ኳንቲቲስ በሚለው ዩኒት ውስጥ የመጨረሻውን ሴክሽን 1.5 ቬክተር ሪዞሉሽን የሚለውን ሴክሽን ይዘንላችሁ ቀርበናል። እንደተለመደው ቻናላችንን ሰብስክራይብ፣ ላይክ ኤንድ ሼር እያደረጋችሁ እንድትከታተሉን እንጋብዛችኋለን። What is vector resolution? A number of vectors acting together can be combined to give a single vector. This single vector is called the resultant vector. In much the same way, a single vector can be broken down into a number of vectors. When again added these vectors, it will give us the original vectors. So these vectors which sum to the original are called components of the original vector. In general, the process of breaking a vector into its components is called resolving into components, or you can call it vector resolution. To make it clear, let me show you with an example. Let's consider here vector A. Vector A. As I told you, when you draw a vector, you must use a ruler and a protractor. This is vector A. Let me say this is vector A. It has a component B. Let's say this is vector B. Okay, let's say this is vector B. Let's say this is vector B. This is vector B. And let's say it again, this is vector A. This is vector A. This is vector A. This is vector A. These are two different vectors which are acting together. When we combine these two vectors, we'll get another vector is called a resultant vector, which is represented as R. This is R. This is the resultant vector. This is the resultant vector. In the same way, this resultant vector can be broken down into components. So, when again we add the components, or sum up the components again, when they are sum up, they will give us again the resultant vector. So, the process of breaking a vector into its components is called resolving into components, or you can call it vector resolution. Let me show you one example again how to resolve a vector. Let's consider this is one vector which is a resultant vector. This is R. This is R. So by representing or by having a plane, xy plane, by having the xy plane, by having the xy plane, this is x direction, this is the y axis. By having this coordinate system, you can resolve this vector into Rx relative to the x-axis. Rx, this is a y-axis which is parallel to the y-axis. This is another one which is ry, the ry component. This resultant vector has two components, which is the Rx and the Ry. The Rx is relative to the x-axis, the Ry is relative to the y-axis. There is an angle called here, there must be a theta relative to the x-axis. In this way, Rx and Ry, when we add or combine them, they will give us the resultant R. Again, this resultant, when we break the resultant, it will give us Rx and Ry. The overall process of breaking a resultant vector or a single vector into its components is called vector resolution. Let's see different methods of vector resolution. The first method is graphical method of vector resolution. The following are the steps that you follow to resolve a vector graphically. The first one is select a scale. You must select a scale and draw the vector. A vector to scale inappropriate to the direction. When you select a scale and draw a vector, you must select the appropriate direction. The second one is extend the x and y axis from the tail of the vector to the entire length of the vector and beyond. The third one is from the arrowhead of the vector, construct perpendicular projection to the x-axis and the y-axis. Draw the x components from the tail of the vector to the intersection of the perpendicular projection with the x-axis. Label these components as x, and draw the y components from the tail of the vector to the intersection of the perpendicular projection with the y-axis. Label these components ay, and measure the length of the two components and use the scale to determine the magnitude of the components. Here, figure 1.13 shows us the horizontal ax and vertical ay components. Here, to make it clear, we do have one vector which is called, this is vector A. This is a single vector. This is a single vector. So when you draw a vector, you must have what? You must have what? You must have, or you must select a scale and draw the vectors in appropriate direction. So here, as you see that from vector A, from the tail to the head, the vector A is drawn and the appropriate scale is represented. The second one is extend x and y axis from the tail of the vector to the entire length of the vector. Here is the tail vector. Here is the tail. From this, you must extend the y axis. This is the y axis. This is the y axis. And again from the tail, you must extend. ለስዕሉ እንግዲህ ይቅርታ ጠይቃችኋለሁ። This is the x axis. Here እንደምታዩት እዚህ ጋር ከቴሉ y axis ኤክስቴንድ ሆኗል። y axis ኤክስቴንድ ሆኗል ማለት ነው። እንደገና again እዚህ ጋር ምን ሆኗል ማለት ነው? x axis ኤክስቴንድ ሆኗል ማለት ነው። ከዚህ በመቀጠል በሶስተኛ ደረጃ from the arrowhead of the vector construct perpendicular projection to the x axis and y axis. ስለዚህ ከዚህ በመቀጠል ምንድነው perpendicular projectionን መስራት አለብን ማለት ነው። ስለዚህ ይሄ y axis እቺም እንደገና ምን መስራት አለባት? which is parallel to the y axis. እዚህ ጋር እንደምታዩት parallel የሆነች ፕሮጀክሽን አለች። እዚህ ጋርም x axis ላይ ምን አለች? parallel የሆነች ፕሮጀክሽን አለች ማለት ነው። parallel የሆነች ፕሮጀክሽን የሚላት ይችላል። ስለዚህ እዚህ ጋር y ኮምፖነንት አለ። ከዚህ በመቀጠል ምንድነው የኤክሱን ኮምፖነንት ሆሪዞንታል ፕሮጀክሽኑ ላይ x ብላችሁ ሰይሙት። it is relative to የኤ ኮምፖነንት ነው፣ ግን it is within the x axis ከሆነ ax እዚህ ጋር ax የተባለበት ምክንያት። እንደገና again ይሄኛውን ay ትሉታላችሁ ማለት ነው። ስለዚህ ይሄ ቬክተር a ማለት ነው። by having the y and the x components ax እና ay ተብሎ ሌብል መደረግ አለበት ማለት ነው። እዚህ ጋር እንደምታዩት ፕሮጀክሽኑ አለ። ይሄን ፕሮጀክሽን ay ብለናል። እቺኛቱን ፕሮጀክሽን ዶት ዶት እያደረግን x ብለን ሰይመናታል። ከዛ በኋላ ምንድነው measure the length of the two components and use the scale to determine the magnitude of the components. ነገር ግን how we can find ax and ay mathematically ነው። ax እና ay እንዴት mathematically እንፈልጋለን? ስለዚህ to find ax and ay you can use the trigonometric function. How you are going to use the trigonometric function የሚለውን the second methods of vector resolution is trigonometric method. When we work on the trigonometric method, I will show you how we are going to use the sine and the cosine and the tangent function to find the components of ax and ay የሚለውን እናያለን ማለት ነው። Here the second ways of vector resolution is trigonometric method of vector resolution. The trigonometric method of vector resolution relies on an understanding of the sine, cosine, and tangent function. You can find the component by using trigonometry. The components are calculated according to these trigonometric methods of resolution. So let's see the method, how the method works. Let's see. Let's consider, as I told you previously, here is from tail to the head, here is the vector A. So you must draw or extend from the tail, the y-axis, and from the tail again you must extend the x-axis. And you must find the vertical projection of the resultant vector, which is here AY. And you must find again the horizontal projection of the vector A, which is ax, the x component is relative to the x component, the x-axis, relative to the x-axis, that component you call it ax. So, how we can calculate ay and ax mathematically? So, let's calculate cos theta. What does it mean, cos theta? Cos theta means it is adjacent side over hypotenuse. When you consider this theta, the adjacent side is the x component. The adjacent is ax. The adjacent one is ax. So the adjacent side is here ax. And the hypotenuse is from, if you consider this is a triangle, this is a 90 degree. Okay? The projection of the y components and the projection of the x, they make 90 degree, which is perpendicular here. So from Pythagoras theorem, this is hypotenuse. Okay, this hypotenuse is under the radical, it is ax square plus ay square under the radical. So this is, if it is 90, this is the hypotenuse is a. So adjacent side over hypotenuse means the adjacent is relative to the horizontal of the angle theta, which is found in the x-axis, that is ax, and the hypotenuse e. The hypotenuse is a. So here, as you see, cos theta is equal to ax over a. So from the crisscross principle, when you crisscross it, so ax will be a cos theta. So here we call it a cos theta. Ax is a cos theta. Let's come to again sine function. Sine means opposite side over hypotenuse. The opposite side here is the ay. The side which is found opposite to the angle theta is ay. So the opposite side is ay, and again the hypotenuse is a. So sine theta here sine theta will be sine theta. Sine theta will be ay over the hypotenuse a. So from here ay will be a sine theta. Ay will be a sine theta. Having this, you can see the original vector is the sum of the two components or the two vectors. So when you add them, the sum will be a equal to ax plus ay. But here, because ax and y are at right angle triangle, here x and y are at right angle triangle. When x and y are at right angle triangle, so the magnitude of the resultant vector can be calculated using Pythagoras theorem. So a will be under the radical ax square plus ay square. In the place of a, you are going to substitute a cos theta, and in place of ay, you are going to substitute a sin theta. So this will gives us the resultant vector. This will gives us the resultant vectors. But if it is the two components, if the angle is not theta, or if the theta is not 90 degree, we are going to use a equal x plus ay. X plus ay. Especially this pretty simple works when the two vectors are in parallel and when they are in the same direction. Here what will be the direction? The direction is calculated using tan theta. Tan theta, as I told you before, tan theta equal to opposite side over adjacent side. So the opposite sides of theta is ay, and the adjacent is the horizontal one within the x component, which is ax. So tan theta equal to ay over x. So tan equal to, theta will be, or theta equal to tan inverse of ay over ax. So the resultant will be, here is a under the radical x square plus ay square. Then the direction will be tan inverse of ay over ax ይሆናል ማለት ነው, when we use a trigonometric function to find the real solutions of two vectors ማለት ነው. Again, when you combine these two vectors x and ay, we will find a single vector. That single vector is called a resultant vectors. Again, that resultant vectors, you can call it a, and again we can resolve, or you can break down this resultant vector a into its components like x and y. That is the concept behind it. Let's see an example. Example 1-2. Here a motorist undergo a displacement of 250 km in the direction of 30 degree northeast. Resolve these displacements into its components. You can see here from the figure resolving of resultant displacement. So here is from the center you can draw a displacement of 250 kilometer in a direction of 30 degree north of east. You can use a compass as a reference direction, as I told you before, or you can use a horizontal plane. So here you can use a compass here, and you can draw the y projection. Here is the y. From here, from the center, you can extend the y axis. Here is the y axis, and again this is, you can extend the x axis. This is the x axis. Then from the center you can draw, this is the north direction, this is the north, this is north east direction. Again this one is the north west direction. So from the center, northeast of 30 degree means northeast of 30 degree, always you must draw your theta with relative to the x-axis. So northeast of 30 degree means here 30 degree. Here is theta is 30 degree. So it has two components. The first one is sy component. The second one is sx component. You can call the sy components Sn to the north direction, because this is, you can consider the y-axis as a north. can consider the y-axis as the north, and you can consider the x-axis to the east direction. So here is the southeast direction. Here is the southeast direction. So s y components, and here is s. I mean, here is not south. Here is sn means displacement to the north direction. South እንዳይመስላችሁ. Displacement to the north direction, and displacement s to the east direction. At the top ራሱ ምን አለው ዳይሬክሽን ቀስቷን ያሳያል። ዲስፕሌስመንት መሆኑን የሚያሳየው እንጂ ሳውዝ እንዳይመስላችሁ። ስለዚህ ኤስ ሂር 250 ኪሎ ሜትር ነው። ዳይሬክሽኑ 30 ዲግሪ ነው። ፕላስ 30 ዲግሪ ሆኖ ኖርዝ ኦፍ ኢስት ነው። ኖርዝ ሆኖ ቱ ዘ ኢስት ነው። ኖርዝ ቱ ዘ ኢስት ከሆነ ሁለት ኮምፖነንት አለው። ኖርዝ ቱ ኢስት ካል ኖርዝ ኮምፖነንት እና ኢስት ኮምፖነንት አለው። የኖርዙን ኮምፖነንት ዲስፕሌስመንት ቱ ዘ ኖርዝ ዳይሬክሽን ኤንድ የኢስቱን ኮምፖነንት ደግሞ ዲስፕሌስመንት ቱ ዘ ኢስት ኮምፖነንት ብለን ነው ካልኩሌት የምናደርገው። ስለዚህ እዚህ ጋር ቀደም ብሎ ባየነው መሰረት ስለዚህ ኤኤክስ ማለት ኤኤክስ የሚባለው ኤኤክስ እያልን ሪፕሬዘንት የምናደርገው እዚህ ጋር ማንን ነው? ኤኤክስ እያልን ሪፕሬዘንት የምናደርገው ኤስኢ ነው ማለት ነው። ዲስ ኢዝ ኤስኢ ነው። ዲስፕሌስመንት ቱ ዘ ኖርዝ ዳይሬክሽን ያለው ደግሞ ኤዋይ ነው ማለት ነው። ስለዚህ ኤስኤን ማለት ምን ማለት ነው? ኤስኤን ማለት ምን ማለት ነው? እዚህ ጋር እንደምታዩት ኤስኤን ማለት ዋይ ኮምፖነንቱ ነው። ኤ ሳይን ቴታ ነው ማለት ነው። ኤ ሳይን ቴታ። ስለዚህ እዚህ ጋር ምን ታደርጋላችሁ? ይሄ ኤስኤን ማለት ኤስኤን displacement to the north direction is equal to displacement ራሱ ዲስፕሌስመንቱ ሲባዛ ሳይን ቴታ ነው። ሳይን ቴታ ነው። ይሄ በሌላ መንገድ ይሄ ኤስ ዋይ ኤስ ኤን የምንለው ከዚህ በፊት ያየ ነው። ኤስ ዋይ ወይም ኤስ ኤክስ ኤ በሚሆንበት ጊዜ ኮምፖነንቱን ሪዞልቭ ያደረግ ነው ኤ ዋይ እና የዋዩን ኮምፖነንት እንደገና ኤ ኤክስ እያል ነው አይደል ሪዞልቭ ያደረግ ነው። አሁን ደግሞ ኤስ በሚሆንበት ጊዜ ዲስፕሌስመንት ነው። ዲስፕሌስመንቱን ኤስ ዋይ እና ኤስ ኤክስ ብለን ነው ሪዞልቭ የምናደርገው። ሁሉም ዲስፕሌስመንቱን የሚያሳየው አሮ መኖር አለበት። ኤስ ዋዩ which is displacement to the north ነው። ኤስ ኤክሱ ደግሞ displacement to the east direction ነው። ስለዚህ ኤስኤን ማለት ዲስፕሌስመንታችን 250 ናት። 250 ኪሎ ሜትር ዘን ሳይን 13 ተክተን በምንሰራበት ጊዜ 125 ኪሎ ሜትር ይመጣል ማለት ነው። እዚህ ጋር ሳይን 30 ዲግሪ ሳይን 30 ዲግሪ is equal to 0.5 ነው። እነዚህ ነገሮች ሳይንስ 30 ስንት ነው፣ ሳይንስ 60 ስንት ነው የሚለውን ነገር just you can given ናቸው። የትሪግኖሜትሪ ፈንክሽን ላይ given ናቸው። በጊቭን ማግኘት ትችላላችሁ ማለት ነው። ኤስኢ የሚባለው ኮምፖነንት ደግሞ ኤስኢ የምንለው ኤስኢ እኩል ይሆናል the displacement s times cos 30 degree ነው። cos 30 degree እዚህ ጋር እኩል ይሆናል ኤስ ስንት ነው? እዚህ ጋር እንደምታዩት 250 ነው። 250 ሲባዛ በኮስ 30 መልሱ ስንት ይሆናል ማለት ነው? It's going to be 260 16.5 ኪሎ ሜትር እናገኛለን ማለት ነው። ስለዚህ how you are going to solve or resolve resultant or a single vector into its components, it is possible in this way. Let's see our next example, which is example 1 to 3. A boy walks 3 kilometers due to east. A boy walks 3 kilometers due to east, then 2 kilometers due to north. What is the magnitude and the direction of his displacement vector? እዚህ ጋር እንደምታዩት ይሄኛው ሁለቱ the boy walks 3 kilometers to the east. እዚህ ጋር ይሄንን እንደምትወስዱታላችሁ እንደ ፕሌንስ ኦፍ ሪፈረንሳችሁ ዋይ አክሲሱን እንደዚህ ኤክስቴንድ ይሄኛውን ደግሞ እንደዚሁም ኤክስ አክሲስን እንትን ማለት አትርሱ። በዚህ ፕሌን ኦፍ አክሲስ ነው ነገሮችን ፊልም እናደርገው። ስለዚህ ከዚህ ከኦሪጂኑ ተነስተን 3 ኪሎ ሜትር ወደ የት ሂዷን ማለት ነው? ወደ ኢስት ሂዷን። እንደገና አጌን 2 ኪሎ ሜትር ቱ ደ ኖርዝ ነው ሄደው። ስለዚህ ኢስት ዳይሬክሽን እና ኖርዝ ዳይሬክሽን 90 ዲግሪ ነው የሚያደርጉት። 90 ዲግሪ ነው የሚያደርጉት። ስለዚህ ይሄ 90 ዲግሪ እንደሆነ ኮንሲደር አድርጋችሁ ነው የምትሰሩት። ስለዚህ ዲስፕሌስመንት ሪዛልታንት ዲስፕሌስመንቱ ወይም ማግኒቲዩዱን የምትጠቀሙት በምንድን ነው ማለት ነው? በፓይታጎረስ ቴረም ነው ማለት ነው። ስለዚህ ምን ይሆናል ማለት ነው? ይሄኛው ሁለት ኮምፖነንትስ አለው፣ ኤስኤን እና ኤስኢ ኮምፖነንት አለው ማለት ነው። ስለዚህ ኤስ ሪዛልታንት ኤስ ዊል ቢ ሪዛልታንት ማግኒቲዩዱ ምን ይሆናል ማለት ነው? እኩል ይሆናል ሆኖ አንደር ዘ ራዲካል አንደር በራዲካል ውስጥ ማለት ነው። በራዲካል ውስጥ ኤስኢ ኮምፖነንቱን ስኩዌር አድርገን the components of AC plus again the components of distance into the north direction አለ። በኖርዝ ዳይሬክሽን ያለውን እነዚህን አንደር ስኩዌር አድርገን ማለት ነው። የሁለቱ ስኩዌር ማን ይሰጠናል ማለት ነው? the magnitude of the displacement ይሰጠናል። ስለዚህ to the east direction 3 ኪሎ ሜትር ነው የተጓዘው 3 ኪሎ ሜትር ስኩዌር ፕላስ to the north ደግሞ 2 ኪሎ ሜትር ነው የተጓዘው 2 ኪሎ ሜትር ነው። እነዚህን አንደር ዘ ራዲካል በምናስገባበት ጊዜ 3.6 እናገኛለን ማለት። ያ ማለት ምንድነው? እኩል ይሆናል በራዲካል ውስጥ 9 ሲደመር 4 3.6 እናገኛለን ማለት ነው። 9 ሲደመር 4 will find 3.6. this is under radical 13 ነው። ራዲካል 13 ማለት ወደ 3.6 ኪሎ ሜትር ወደ 3.6 ኪሎ ሜትር ነው። ዳይሬክሽኑ ታንቴታ ነው። በታንቴታ ነው የምናገኘው። ታንቴታ እኩል ይሆናል ኦፖዚት ኦቨር አጀሰንት ነው። እንደነገርኳችሁ tan theta is equal to opposite over adjacent ነው። opposite over adjacent ነው። እዚህ ጋር ኦፖዚቱ ማን ነው? የአንግሉ ኦፖዚት ሳይድ 2 ኪሎ ሜትር ነው። 2 ኪሎ ሜትር ዘን አጀሰንቱ ደግሞ ቱ ዘ ኤክስ አክሲስ የምናገኘው 3 ኪሎ ሜትር ነው። ስለዚህ 2 ሲካፈል ለ3 0.66 ነው። ስለዚህ ታን ቴታ እኩል ይሆናል 0.66 ከሆነ ቴታ ምን ይሆናል ማለት ነው? ታን ኢንቨርስ ኦፍ 0.6 ነው። ታን ኢንቨርስ ኦፍ 0.66 ፍሮም ትሪጎኖሜትሪክ ቴብል በምታዩበት ጊዜ ወደ 33.69 ታገኛላችሁ ማለት ነው። this is the direction 33.69 ዲግሪ ነው ዳይሬክሽኑ። ሪዛልታንቱ ግን 3.6 ኪሎ ሜትር ነው ማለት ነው። በአጠቃላይ የ10ኛ ክፍል አዲሱ ካሪክለም ዩኒት 1 ቬክተር ኳንቲቲስ የሚለው መሰረታዊ ሐሳቡ ይህንን ይመስላል። ግልጽ ያልሆነላችሁ ጥያቄ ወይም ገለጻዎች ካሉ በኮሜንት ቦክስ ጻፉልን። ማብራሪያ ይዘንላችሁ እንቀርባለን። በቀጣዩ በዩኒት 2 ማለትም ዩኒፎርምሊ አክሰለሬትድ ሞሽን እስከምንገናኝ ድረስ መልካም ጊዜ ይሁንላችሁ። በድጋሚ ይህ ቻናል ለብዙ ተማሪዎች ይደርስ ዘንድ ላይክ እና ሼር ማድረግ እንዳትረሱ። ለቻናላችንም አዲስ የሆናችሁ ሰብስክራይብ ማድረጋችሁን እንዳትረሱ። እየተከታተላችሁን ስለሆነ እናመሰግናለን።